And we are going to, I'm just going to kind of go back through everything we've learned so far in chapter 8, and we're going to kind of pull it all together. Okay, so let me borrow this. This is that Desmos. Remember I was telling you about that, the graphing calculator. But we don't even need Desmos quite yet. So what we are going to do is we're going to kind of take a walk back through our notes, right? So this whole chapter 8 is all about equations that have two variables. Okay, so we have x and y. Those are the two variables that we mostly have, right? And we want to know, how do we represent those visually on a graph? I mean, you guys were all hoping to learn that. I know at the beginning of the year, like, how do I represent x and y, right? So let's flip over here. Okay, so what do I mean by that? I mean, if I have the equation like, let's do this, y equals, what happened to my pen? There we go. Y equals 2x plus 1, and I wanted you to solve that. You'd be like, okay, well, hopefully you guys are a little closer to knowing how to solve that, right? Is there just one answer to this equation? No, right? There's more than one x and y that can make this equation true. Okay. And so we said, well, how do we solve this? And I remember, Sophia, you were my chart person on Monday, right? I would say, how do you solve this? And you say, make a chart. So I can just make a chart. My computer thinks I'm trying to open up a new window. All right. And I can say, oh, okay, well, when x equals, my favorite, when x equals 0, y equals 2 times 0 plus 1, or y equals 1. So when x equals 0, y equals 1. Okay, and this right here, this 0, 1, is one possible solution to my equation. We call this a coordinate point. Okay, and we call it a coordinate point because it corresponds to coordinates on the graph, and you need to be able to graph those, right? And so we would graph it something like this. X equals 0, y equals 1. So that means on my graph here, x equals 0. So that means it's not going anywhere. And y equals 1. So if I want to graph that point, it would be right here. Okay. But in order to kind of get a better feel for my line, I need a few other points. So let's pick another one. So let's say, what happens when x equals 2? Okay. When x equals 2, y equals 2 times 2 plus 1. So 2 times 2 is 4, plus 1 is 5. So when x equals 2, y equals 5. So this is another point at 2, 5. This is also a solution to y equals 2x plus 1. Okay? And where is that point on the graph? That's when x equals 2. So this is, remember, our x-axis. So x equals 2 is right here. Right here. And y equals 5 is up here. So that's another possible answer to our equation. To be really safe, let's go ahead and do another one, just for fun, right? Let's do when x, whenever I draw sideways like that, my computer thinks I'm like scrolling. Okay, so when x equals -1, what happens? So what do you think when x equals -1? What does y equal? Can somebody do that for me? So -1 times 2 is -2 plus +1. So -2 plus +1 would be -1, right? So another point is -1, -1. And these are all all of these coordinate points are answers to this equation. Okay, so that point is at -1, -1, -1 down here. Okay, so now if we play connect the dots, we have 3 points. All right, if I connect from -1 up here, play dot to dot, right? This line represents every answer to this equation. Okay, so if I didn't plot this, but here is -1, -1, right? We said that was one answer. Another answer is 0, 1. Another answer up here is 2, 5. Because I actually drew my graph accurately, it looks like, see right here? It looks like there's another answer here. That's when x equals 1, y equals 3. X equals 1, y equals 3. We can check and see if that's a solution, right? When x equals 1, it's 2 times 1 plus 3, and that's a solution. Anything on this line, and the line keeps going up and keeps going down forever and ever, anything on that line is an answer to this. So there's not one single answer, right? Everything on that line is the answer. So is that kind of starting to sink in? Like, oh, okay, that's what the point of graphing it is. That you could pick any point, and there's some in here that aren't exactly on the line. It looks like right here, when x equals 1/2, y equals 2. Looks like about a point on there. So that makes sense-ish? Okay. Olivia, Sophia, and Jack. Does that make sense? Okay. Cool. All right, so then we learned something new on Monday. So this will be new for you, Jake, which was called the slope of a line. So this is a line, right? And really, you only need 2 points to make a line. So I always do 3 points. That's why we did 3 points here, just to make sure that you didn't mess up. Okay, so we need 2 points to make a line, and we have 3 points, and they all line up, so we're good. So we're going to talk about another property of a line, which is called the slope. Okay, so this is a good review of slope. So this is 8, is it 8.3 or 8.4? This is 8.3 that I'm going to talk about right now. Okay, so 8.3, we learned this thing called slope. So slope, there's a lot of different definitions, but the one that people tend to remember is the rise over the run. Okay, and the other weird kind of thing about slope is that you can mark it as M. All right, so what does this mean? Well, this means that if I wanted to find the slope of this black line right here, right, I want to find out how much does it rise versus how much does it run. So rise is your up and your down. So what you can do is you can take any 2 points on here and you can figure out the slope. So let's take this point right here, and we'll go all the way up here. Okay, so to get from my first green point to my second green point, I need to rise 1, 2, 3, 4. Okay, so I rise up 4 spots. Okay, but I'm not quite there to my spot yet because I have to run. I have to run across here 1, 2 spots. Okay, so my slope of this line is the rise over the run. For every 4 units I rise, I run 2 units. or I have a slope of 2 over 1. And so that means anywhere on this equation, so like say I start down here at -1, 1. If I rise 2, 1, 2, I run 1. If I rise 2, 1, 2, I run 1. Rise 2, run 1. So that's how that all kind of comes together. And then the last thing that we talked about, okay, so any questions about slope? Slope just, that makes sense? Okay. The last part that we talked about on Monday, we guys like, is we talked about something called the slope-intercept form. So if something is written like y equals, I know this paper is getting ready, mx plus b, okay? So if something is written in this format, the m represents your slope. So the number before the x is your slope. And guess what? Here it was 2, and we found out that the slope was 2. Thank you, Evan. Love you. Okay, so we actually can use several different ways to find the slope. And actually, Jake, there's a formula to find the slope too, which you can do it without graphing it. You can actually use a formula. So I'll make sure that we update you on that. But then also, if you put your equation in this format, y equals mx plus b, you can just look whatever number is before x is the slope. Okay. And whatever number is being added at the end, plus 1, that's the y-intercept. So look at where does this hit the y-axis? It hits the y-axis at plus 1. So these things are all like kind of interconnected. We're learning all of the different things at once, right? So we're going to pick up with that. Does anybody want to see anything like is this good review? You guys ready to keep going? Okay. All right, give me just 1 second here. Let me get a drink of water and then we'll keep going. Sorry. Okay, so now let's get back to 8-4. This looks so beautiful. So sad to see it go, right? All right, so 8-4 is called the slope-intercept form of a linear equation. So this is what I was just talking about. We gave you like a sneak peek of this, right? Y equals mx plus b. So the trick is, and I think I tried to trick you earlier with this or something. If your equation looked like, oh no, we were looking at some other homework. That's what it was. If you have an equation like, if your computer will let you write an equation, come on, computer. It's like not letting me write on there. All right, I think we might just have to switch to Paint. Okay, so if your equation is 2x plus 3y equals 4, Is this one of those linear equations that we've been talking about this whole chapter 8? Well, it is because it just has an x and a y, right? And so there's different values of x and y that can solve this. So this is a linear equation and it can be graphed as a line. That's where the word linear equation comes from, because you can graph it as a line. But it's not written in the slope-intercept form. So what I mean by that is, in order to use this cool little trick of the slope-intercept form, it has to be written as, your equation has to be written as y equals mx plus b. If your equation is written in this format, so it's kind of like a format thing, then you can easily look and see, oh, whatever before the x is my slope, and whatever the b is my y-intercept. Okay? So that's kind of the catch with this. You're like, this is so easy, right? I can totally look what's before x and b and figure out what my slope and my y-intercept is. But it has to be in this form. So that's the one watch out with that. Okay, so let's switch back to the notes. You've got the slope-intercept form right there. Yes. Okay, so let's do some examples, okay? I think we did these in class, so maybe. Yeah, I think we did these in class, but that's okay. I don't remember if we did or not. Okay, so if I have y equals negative 2/5 x minus 5, is this the standard slope-intercept form that I was talking about that we have to have? Yeah, right? You don't know? Okay, well, the answer is yes. Here, we'll do that. Paint's always nice to me. Let me write on it. Okay, so you want it to look like this. Y equals mx plus b. And this does look like y equals mx plus b, even though it's really light, right? So your slope of this equation is going to be whatever is before the x. So you would say that the slope of this equation is negative 2/5. Okay, and the y-intercept, this is kind of the tricky part. See how it's minus 5? Well, the standard equation is plus b. So another way to write minus 5 is plus a negative 5. So that means that my y-intercept is at negative 5. So those will be my characteristics of that equation. Okay. So erase. Oh, that's not what I meant to do. Okay, I'm going to kind of take it a little bit further. Do you remember how I told you guys about Desmos and how it can help you graph things? We're going to take a little further and we're going to actually graph this so you can see what I mean. So my equation, right, is y equals negative 2 divided by 5 times x minus 5. Okay, so this is my equation. Let me pull it up bigger here. You can see the equation here and you can see the graph over here. So the first thing to note is we said my y-intercept, where it hits the y-axis, is at negative 5. And you can see right here that this graph hits the y-axis when y equals negative 5. So that kind of matches up, right? Our slope is negative 2/5. And I actually want to show you this on the graph. So let me fix up my graph a little here. So there we go. I like it when it has the numbers on it too. Okay, so we said that the slope, please work. For whatever reason, it's not letting me, I have to like bring it over to Paint to do this stuff, which is kind of not fun. There we go. Okay, so we said that our slope right, was negative 2/5 because that was what was before our x. So let's actually check our graph and make sure that we understand what this slope of negative 2/5 means. Okay, so slope means the rise over the run. Okay, so we have a negative here, so we need to put that negative with one of them. So I'm going to put it with negative 2/5. I'll show you that you could do it the other way too, but we have to pick one side for the negative to go on. So I'm going to make it rise negative 2, run positive 5. So you can pick any random point on here. I'm going to pick this point here. Okay. I said that my slope is that when I rise negative 2, so rising negative 2 means going down negative 2, right? When I rise negative 2, I run positive 5. So it's 1, 2, 3, 4, 5. So that's another way to check, okay, I got the right slope. What if instead of picking my negative sign to go with the 2, I made it go to the 5. So instead of my rise over run, instead I said was 2 over negative 5. Because negative 2 over 5, negative 2 over 5, or 2 over negative 5, all of these mean the same thing, right? So if I pick that point, I'm actually going to start down here, okay? This would mean that I need to rise 2, and I need to run negative 5. So it's just a difference of which way you go, but either way, you're going to end up in the same spot. So how does that feel? Is it making sense? Like all starting to get connected? Okay. We did, but I just want to make it all kind of come together because you'll see the next thing that I'm going to make you do. Well, let's finish up these last few things here, or these last, I guess, few problems. So number 2 is y equals 4 minus x. So who thinks they can tell me what the slope of that line is? All right, what's the slope? Trick question, right? Okay. What is it? The slope equals -1. That's great. Okay. And what is the y-intercept? Yep. That's it. Okay. Yay. All right. What about number 4? Who wants to do number 4? Y equals 9 minus 3x. So what would the slope of that be? -3. Yeah. And what would the y-intercept be? 9. Nice. All right. What about number 3? Y equals 2. Yeah, nice. The slope is 0, right? And what about the y-intercept? Yep. You guys got it. Okay, so now this is the trickier part. Not too tricky, but a little bit trickier, okay? So now the second part of this is Use only the slope and the y-intercept to graph each equation. Dun, dun, dun. All right. So the first thing we have is y equals 3 divided by 2x minus 4. Okay. So what is the slope of this equation of number 5? Yep. So the slope is 3 over 2, right? And what about the y-intercept? Yep. All right, so we've got those two things. Now, just using those two pieces of information, can we graph it? That's the challenge, right? And the answer is yes, we can totally graph it. Let me get a nice little graph. I used to have some like graph paper I could pull up. And I keep telling you guys I'm going to send you that, which I do need to do. What? Oh, cool. All right. I want to have some. Okay, so let's see. So we said our slope is 3 over 2 and our y-intercept is at -4. So I wish I could have these both up at the same time, but I can't. Okay. Back to where we were at. Come on. All right. Our slope is 3 over 2, and our y-intercept was what? Y-intercept, was it -4? I just deleted that. I can go back here and look. -4. Okay. So let's graph this with just this information. So the first thing you always want to graph actually is your y-intercept, because that gives you a starting point. So the y-intercept is, this is the y-axis right here, right? And it's where it hits the y-axis. So it hits the y-axis at -4, which is right down here. So boom, you have 1 point on your line. You're halfway there, right? Your slope is 3 over 2. So that means that for every, I rise 3 and I run 2. So if I want to draw my slope, that means I need to rise 3. So 1, 2, 3, and then run 2. 1, 2. So another point on my line will be right here. Okay. And then just to make sure I'm doing all right, I'm going to rise another 3 and run 2. So rise 3, 1, 2, 3, run 2, 1, 2. That was not so good, but you guys get the picture. So I have another point right here. So then if I actually want to graph the line, what I want to do is I want to play connect the dots. And I want to connect my dots all the way through. And so now this green line represents every point on my original equation. So my original equation was, that's a line. My original equation was y equals 3 over 2x minus 4. So if I pick anywhere along this green line, that is an answer to y equals 3 over 2x minus 4. Okay? And actually, if I go into Desmos and I graph this, you can double check that your graph looks right, right? So y equals 3 divided by 2 times x minus 4. So you can see this is where your y-intercept is at, right? And if I rise 3, 1, 2, 3, I run 2, 1, 2. Rise 3, 1, 2, 3, run 2. Rise 3, run 2. And then the cool thing about Desmos is that you can sit here and drag along any point. So it looks like when x equals 2.666, which is 2 2/3, y equals 0. And when x equals, let's say, you can pick any number. Oh. When x equals 6, y equals 5. And you could keep going down here, right? When, x equals -4, y equals -10. So being able to have an equation, graph it, is actually really powerful because then it gives you all of the solutions to the equation. And it's just cool, right? That's what you guys were all thinking. I'm so glad that I woke up to do this cool thing. Not as bad as where from. Oh, well, there's an upside, right? All right, so let's do one more. We have 3x plus y equals 2. So if I have 3x plus y equals 2, and I wanted you to graph this using just the slope and the y-intercept, what do you think we need to do first? You got it? All right. What'd you do? So here's, okay. Yeah, you got to move that. You got to make it look like y equals mx plus b, right? Okay. So how do I do that? I have to move my 3x to the other side, right? So you can't do anything. You might be tempted to tell me that the slope is 3 and the y-intercept is 2, but since it doesn't look like that, you have to change it to y equals -3x plus 2. So now, can you tell me what the slope is? All right, what is it, Sophia? You're my slope expert. Well, just -3, right? Your slope is -3, and your y-intercept is 2, all right? I'm just going to draw a little graph here instead of, okay. So it's a fancy graph, right? All right, so my y-intercept is at 2. So that means that that's the first point I'm going to graph is at 0, 2. It's always where you're going to graph first, right? Right here, y equals 2. Okay. The slope is -3. How do you graph a slope of -3? Dun, dun, dun. All right, so if my slope is -3, you can think about this a couple ways. One is that you can always put something over 1. Okay, so my rise over my run is going to be -3 over +1. So that would mean if I go to graph my slope, I go -3, so -1, -2, -3, +1. And that would be a point. -3, -1, -2, -3, +1. So based off of that slope, I would say that if I connect my dots here, my line goes like this. Okay. Now, if you looked at the slope and you said, I think that the slope is 3 divided by -1, because that's also -3, right? 3 divided by -1 is also -3. Then it also works, right? So if I go here and I say rise +3, run -1, rise +3, run -1, you also end up with the same equation, same slope. All right. So I think it's actually kind of cool. Oh, one last thing. We can go back to our original equation, 3x plus y equals 2, and we can graph it, right? And we can see if we were right. So it was 3x plus 2y equals, what's it? Oh, 3x plus y equals 2. Make sure you get your equation right, or else you won't get it right, right? 3x plus y equals 2. All right, and so when we graphed our equation by hand, we actually got pretty close, right? And you'll see that it hits the x-axis or the y-axis at 2, and it hits 0 at this number here, which looks like 2/3 and 0. So that looks about right on our graph. And then any point along this line is an answer. So when x equals 4, y equals -10 is an answer for this equation. All right. I think it's pretty cool. Comes all comes together. It's like everything kind of works together. Yep. And then I'm not going to do all of 985, but I do want to tell you can do at least the first few, or at least the ones that have a slope of 2, like at least this first one. We'll do this really fast, okay? And then the rest we'll kind of tackle on Monday. So what we should be able to do, before we said, oh, well, we have an equation and we can find the slope and the y-intercept. What if they tell you the slope is 2 and the y-intercept is 15? Could you write an equation of a line that has this property? Yeah, right? So you would just say the slope is 2. Sorry, having technical issues today. The slope is 2, and the y-intercept is 15. So your equation is y equals mx plus b. So your equation for a line with a slope of 2 and a y-intercept of 15 would be y equals 2x plus 15. That's all you would do to write that equation. Okay? And then we're going to get a little more fancy and we're going to have 2 points and find the slope and write the equation. But at least the first few homework problems in 8.5 you could tackle if you feel like doing that. Yep, we're all the way up to 8.4. Okay, well, I think that's where I'm going to end today. The only other thing that I was going to do, if you want to stay on, Jake, I don't know if you need to get going, and anybody else that wants to stay on, I was going to review a little bit more of slope, where you use the y2 minus y1 over x2 minus x1. So if that was confusing to you, or you would just want to see it again, you can stay on. If not, then you're free to go. So Jake, do you have a minute to go over that? Okay, because this will be what's when we start on Monday, we'll kind of have to have the same knowledge. So just to kind of review for everybody, since you're all still on, and if anybody hops off, I'm not offended. We talked about slope equals rise over run, right? And I think visually you guys all got it, which is awesome. There's also an algebraic way to get this, to get the slope of an equation, which you also have to understand or know, okay? And so what I mean by that is that you can find the slope by doing y2 minus y1 over x2 minus x1. You're like, oh, where did that equation come from? It's actually the same equation. So we said the slope is the rise over the run, right? And what we're talking about when we talk about rise is how much is y changing, right? This is how much does y change, the rise. And the run is how much does x change. So when you translate into algebra, it's the change in y divided by the change in x. So it's the same idea. It's the change in the rise, which is the change in y, over the run, which is the change in the x. Just that all of a sudden you're going to get this y1 minus, or y2 minus y1 over x2 minus x1, and you get this equation, and it's like, whoa, what a second. I understood slope when I could see it visually, but then I've got all these numbers. So we also need to be able to take, when we have 2 points, and to be able to figure out the slope without necessarily just putting on a graph every time. I mean, you can graph it every time, but sometimes you're going to get those points that just really you can't graph easily, if that makes sense. So one example would be like this example number 2. So I have a point at 7, -6, and a point at -5, 2. And I want you to find the slope of the line that passes through both of these. So I want you to find the slope of a line that passes through these 2 points. Again, you could graph this, right? And we could figure out what the slope is. But sometimes graphing it just isn't going to be practical, or it's going to be just too hard to figure out what the slope is based off the graph. So sometimes we have to use the equation. And so the equation is the rise over the run, and the rise is talking about the change in the y, right? So we need to figure out how much does y change. And so what I like to do, just from I can't remember which one goes where. I like to label my points. So I just randomly say this is x1, y1, x2, y2. So I'm going to see how much does my y change. So my y changes from 2 to -6. And my x changes from -5 to +7. And we subtract because that gives you the difference between the two. So if I do 2 minus a -6, I get +8. And if I do -5 minus 7, I get -12. So my slope is going to be -2/3. And I'll do another example, but I just kind of wanted to give you the idea. Like, we're talking about how much does y change over how much does x change, and we're actually using the numbers versus the graph. Now you can use a graph. So if I go over to Desmos and I put in these points, so my points are at 7, -6, right? And I have a point at -5, 2. All right, so if I actually graph this, and then I try to figure out my slope just by looking at this, let's see if we can do it. Okay, so I rise 1, 2, 3, 4, 5, 6, 7, 8. I rise +8, and I run -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12. So I actually rise positive 8 and run negative 12, which is what I got when I subtracted the numbers, right? Which is the same as negative 2 over 3. Bye, Sophia. So that's how that kind of all relates together. So let me do another one of these with just, like, we'll just look at the equation. So the slope is always the change in y, which is y2 minus y1, over the change in x, which is x2 minus x1. If you have 2 points, it doesn't matter which ones are your y2, x2, y1, x1, as long as you keep them consistent. So that's why I always just randomly label mine x1, y1, x2, y2. So I can just plug in and get the right answer. So for this particular one, my y2 is negative 4 minus y1, which is 2, over x2, which is negative 3, minus x1, which is 1. So negative 4 minus 2 is negative 6, and negative 3 minus 1 is negative 4. And so it turns out the negative divided by the negative makes it positive, and it's a slope of 3 over 2. If you would have picked opposite and made this one x2, y2, and x1, y1, it would have turned out the same way. Because you're really just talking about the change, and it kind of works out. So does that make sense, Jake? Okay. Sure. Just what you wanted to do, right? All right. Cool. Yeah, and then that'll help on Monday, so you won't be like, what's going on? Good deal. Well, thanks for sticking around for a little bit longer. All right. You guys have a great weekend. Hopefully everybody feels better. I know. Elijah told me everybody in your family was sick, which does not sound fun. Except, yeah, that's what he told me. He's like, I got sick and then now I'm fine and everybody else is sick. Like, thanks.